Okay, so next we are going to look at number 23. Okay, so for this one, it says rectangle ABCD has a diagonal with a length of 40. What are the dimensions of the rectangle? Dimensions just mean what is the length and width. So it wants you to find these other sides. Okay, so I'll call this X and I'll call this Y since we're going to have to solve for both of them. Okay, so this is another SOHCAHTOA problem. So let's say we want to solve for Y first, or actually let's just go ahead and label the sides first. So this would be our hypotenuse side, this is our adjacent side, and this is across, so this would be the opposite side. Okay, so in the previous video we went into depth on like how to set up SOHCAHTOA. I'm not going to go as much in depth on this problem. If you want to look at that, look at the previous video. Okay, so for X is going to use the adjacent side and the hypotenuse side. So adjacent and hypotenuse goes with cosine. So we'd say cosine of 39 is equal to X over 40. Okay. When X is on top, you're going to be multiplying by the number on bottom. So X is equal to 40 times the cosine of 39. Let me get my calculator. 40 cos 39. Make sure you're in degree mode again. And then it's 31.2 roughly. 31.2 degrees. Wait, sorry, not degrees. That's just the length. Okay. So that's the length for X. So that's one of your dimensions. For the other dimension, okay, Y is your opposite side. We're going to be using the hypotenuse again. So opposite and hypotenuse goes with sine. So sine of 39 is equal to Y over 40. Once again, Y is on top, so we're going to multiply by what's on bottom. 40 times sine of 39 is equal to 25.2. Okay, and there we have it. Okay, next problem. And again, I'm going to be going a little bit faster for these since there's so many. If you need to go back and adjust or like think about this a little bit more, pause the video, look at my work, but I'm going to move on. Okay, so in the kite shown, the measure of angle Q is 90. The measure of angle S is 60. If PQ is 9, what is the length of SR? Okay, so this problem is using your knowledge of triangles as well as your knowledge of kites. So the fact that this is a kite means that this angle P is congruent to this angle R. So I think the first thing that we need to do here is we need to, oh wait, no, we don't even need to do that, sorry. Okay, this is what we're going to do. Haha, okay. We divide this kite into two triangles, this one here and this one here. Now notice, these two triangles are two isosceles triangles. This one's isosceles, this one's isosceles. If you remember your properties, okay, isosceles triangles have base angles congruent. So I can get the measure of these two angles by subtracting 180 minus 60, okay, which is equal to 120, and I split that between these two. So that means that this angle would be 60, and so would this one, okay? This is going to help us out in a minute, because if this is a 60, 60, 60, that means that this is equilateral, which means that whatever this side is right here, these two will be the same. So remember, SR is what we're trying to find, this one right here, okay? So what this is telling us is that if we can get this side, then we'll have our answer, what this is. Okay, now the other benefit is that because I know that this is isosceles and this is 90, okay, this is another 45, 45, 90 triangle. So these two sides would be congruent. And you could go two ways from here. You could use Pythagorean theorem to get this hypotenuse. So you could do 9 squared plus 9 squared. Square root it. That's going to be about 12.7, okay? If you know your 45, 45, 90 rules, then you'll know that this is our x, so this would be x square root 2, so that's 9 square root 2. Now, whether it's in this format or this format, if it's in this format and you want a decimal, just type that into the calculator and see which decimal matches your answer, okay? So these are the same. All right, and that's our answer because we said that once we find this length, okay, this is going to match that length. So x is about 12.7 or 9 square root 2. Okay. Next, given the parallelogram to the right, what is the value of x? So what we know about parallelograms, their opposite angles are congruent, so like these two would be congruent. Okay, those two would be congruent. Their consecutive angles are supplementary. Now I'm not saying this is not the side that's 180. I'm saying that this angle plus this angle equals 180. So this is 5x plus 3 plus 72 is equal to 180 degrees. Okay? All right, after we set it up, it becomes an algebra problem. So 3 plus 72 becomes 5x plus 75 is equal to 180. Okay? I'll do 180 minus 75. Okay? So we get 5x is equal to 105. And then I would need to divide by 5. So x is equal to 21. That's your answer. All right, and the next one. It says, in the diagram shown, the ladder platform and the brace are both parallel to the floor. The brace attaches to each leg at the midpoint. How long is the brace? This is just asking you, what is the length of the midsegment? That's what this question is. And it's really simple if you know how to solve for a midsegment. It's your base 1 plus base 2 divided by 2. So that's going to be 5 plus 10 divided by 2. 15 over 2, 7.5. That's your answer. Okay. All right. Name 2 properties that a square and a rectangle have in common. So squares, okay, all sides congruent, all 90-degree angles. Let's see what else. They have, squares have diagonals congruent, and I'm pretty sure rectangles do too. Yeah. Okay, so one thing, because we know, so rectangles don't have all sides congruent, but they do have all 90. Okay. And they have opposite sides congruent, they have opposite parallel sides. So I'm just going to start listing some things squares and rectangles have in common, because there's a lot. So all 90-degree angles is 1. They have opposite sides parallel. They have diagonals. Diagonals are congruent. Just see. You could say that their opposite sides are congruent, technically. Okay. That's all I can think of at the moment. There's probably more, but this is at least 2. So we did what the question asked. Okay, so then next question. It says place point R so that it creates a right trapezoid. It's going to be for point R. We'll do that one in blue. Place point Z so that it creates an isosceles trapezoid. So we'll do point Z in orange. All right, so it already gave you two sides of the trapezoid. If you want to write trapezoid, that means that this last leg has to come straight down to form a right angle. So that would mean that point R would have to be at 8, 0, okay? So that it comes down nice and straight and forms a right angle. Okay. For point Z, if we want it to be isosceles, that means that this leg needs to match and be congruent to the other leg. So remember, isosceles trapezoids have like a line of symmetry through the middle. So I need to make this leg come out here so that it's perfectly symmetrical with the other side. We can do that by counting the rise and the run of this and mimicking that rise and run over here. So we're going up 8 and we're going over 1, 2, 3, 4. Okay, so I'm going to do that again. We're going to go over 1, 2, 3, 4, and then down 8. So now my isosceles trapezoid is symmetrical and good. So this point Z would be at 12, 0. Okay. Next, a carpenter is making a wooden platter in the shape of a regular polygon. If each interior angle of the polygon is 150, how many sides does the platter have? Okay, this is just a formula, and you have to memorize the formula or write it on the note card that we are allowing you guys to have. So, the formula, if you want to get the number of sides, which is represented by n, it is 360 over 180 minus the interior angle. Okay, so plugging things in, I would do 360 over 180 minus 150. Okay. This needs to come first. Okay, don't do this. What I'm about to do is bad. Don't do it. Okay. Your calculator divides first and then subtracts, and it gives you this crazy answer. I mean, obviously that's wrong. You can't have negative 148 sides. But if you put it in parentheses, just like I did here, okay, that tells the calculator to do this first and then divide. Okay, and you get the answer that's correct, which is 12. Okay. You could also just divide first. 30, 360 divided by 30 is 12. All right, for the next one, it says if each exterior angle of a regular polygon is 15, how many sides does the polygon have? So the formula for this one is easier than the last one, honestly. It's just 360 divided by the exterior angle. So I would do 360 divided by 15, and that gives us 24. Okay, so that has 24 sides. Okay. If a regular polygon has 17 sides, what is the measure of an interior angle? Okay, so if you have the number of sides but you want the interior angle, the formula is this. 180 times n minus 2 divided by n. If you remember back to when we were learning this unit, the part that's on top represents the sum of all of the angles inside of the shape, and then we would divide that by the number of sides to get each individual angle. Okay. So plugging things in, I would have 180 times 17 minus 2 divided by 17. And that's equal to about 158.8. Okay, next one. Flip it over. Okay. So we're going to get into these problems that are all about regular kinds of shapes. Okay. So this question is asking us to find the area of this regular hexagon. So the area formula for a regular hexagon is 1/2 AP, where A stands for your apothem and P stands for perimeter. So before we do anything else, we need to get the length of the apothem. Okay. All right, so we learned this a while back, that the way to do this is you start by creating this right triangle inside of the shape with the apothem. This side gets split in half, so that's 3 and 3. We use our interior angle formula to get one interior angle, so 180 times 6 minus 2 divided by 6. We used this formula for the last problem. So that's equal to 120. Okay. And then we take that, and then this angle right here splits the whole thing in half. So I just divide 120 by 2, okay, and that gives me this interior angle is 60. Okay, I'm going to do some work out to the side because I'm kind of running out of room. Okay, so let's see. All right, so we have this right triangle here. Make it a little bit bigger. This side is 3. This is 60. This is your apothem, what we're solving for. Okay. We're going to use SOHCAHTOA for this. Across from 60, this is your opposite side. 3 is the adjacent side. Opposite and adjacent means to use tangent. So tangent of 60 is equal to the apothem, opposite over adjacent, so A over 3. All right, so tangent of 60 equals the apothem over 3. A is on top, which means that we'll multiply to get it by itself, so those cancel. A is equal to 3 times the tangent of 60. Okay, make sure you're in degree mode. So the apothem is about 5.2, okay, in length. Okay, now this isn't the end of the problem because we still need to get the area. So we have a piece that we need, really the most important piece because the rest isn't as difficult. We also need the perimeter, but that's kind of easy. 6 times 6 sides, okay, would give us a perimeter of 36. So plugging things in, okay, I'm going to kind of do this out here. So 1/2 times the apothem of 5.2 times the perimeter of 36. Times 5.2 times 36 is equal to 93.6. Okay, so that's our area. All right, next. What is the distance of one side of the regular hexagon if the apothem is 6 meters long? So same kind of problem again, but this time the only difference is that we're given the apothem. We need to find the side length, okay? Since it has the same amount of sides, you would do these same steps again. 186 minus 2 divided by 6 gives us 120. Divided by 2 gives us 60. Okay. Okay. So now this time around, okay, opposite, adjacent, we're still going to use tangent. But when we plug things in, we get tangent of 60 is equal to 6 over x. X is in the denominator this time, which means that we're going to need to divide by the tangent of 60. So x is going to be equal to 6 divided by tan of 60. So that's equal to about we'll say 3.46 to be a little bit more accurate. Okay. Remember, this represents half of a side length. These are 2 x's, this is half, okay? So multiply that by 2, and we get that one side length is about 6.92. Okay, next problem. What is the area of the regular pentagon with a radius of 10 centimeters? Okay, so we're going to start this off the same way that we did the others. The difference this time is that we've got 5 sides because of the pentagon. So 180 times 5 minus 2 divided by 5 gives us 108 as the measure of one angle. We divide that by 2. So that gives us 54. That's inside right here. Okay. We're trying to get the area, which means that we actually need to get both sides this time. We need to get both the apothem and this side. Okay. So we're going to have to do 2 SOHCAHTOA problems here. Or you could do SOHCAHTOA and then Pythagorean theorem, your choice. All right, let's start by getting the apothem. So tangent of 54 equals, oh wait, not tangent, sorry. Okay. This is our opposite side. We're going to use our hypotenuse side this time. So that's going to change the fact of whether we use tangent, because opposite and hypotenuse goes with sine. So this time we're going to use sine of 54. That's equal to the apothem over 10. And then A will be equal to 10 times the sine of 54. Okay. 10 sine 54. So that's about 8.09. Okay. All right, that's the apothem. That's just a piece of what we need because we're trying to get the area. So I've done a lot of SOHCAHTOA. I want to show you another way to get x. So one of the other things that you could do, now that we have that this is about 8.09, if you don't want to use SOHCAHTOA again, you have 2 sides now. You can use Pythagorean theorem to get the other. Since I'm solving for a leg, I would do the square root of 10 squared minus 8.09 squared. Oops, sorry, 8.09 squared. And that gives us about 5.88 as the x. Okay. Remember, that's half a side length. Okay. So that means that one side length would be 11.76. Sorry, this is kind of a long problem. Okay. Now, after all of that work, okay, the nice thing is that getting the area is the easiest part. Getting the apothem and the side length are harder. But once you have those things, okay, the perimeter would be 11.76 times 5, since it's got 5 sides. So that's 58.8, okay? We already got that the apothem was 8.09. So plugging things in, 1/2 times 8.09 times 58.8 is 237.8. Oof. Okay. And that's your area. 237.8. That's your final answer. All right. We're done with those kinds of problems. Okay, the interior angles of a hexagon are 110, 90, 85, 92, and 165. What is the other interior angle? So this is where you're going to use the angle sum formula, which is actually part of the formula that we were using earlier. So remember how I said the top is the sum? So instead of taking this and dividing by n, we're just going to do 180 times n minus 2. So if it's a hexagon, okay, that means it has 6 sides. So 180 times 6 minus 2 is equal to 720. Okay. Now the reason we're not going to take this and divide by 6 is because not all of the angles are the same. So what we want to do here instead is we're going to add up the angles that we already have. So 110 plus 90 plus 85 plus 92 plus 165. And that's equal to 542. Okay. And then to get the last angle, because we've got 1, 2, 3, 4, 5, there's 6 angles in total. So 720 minus 542 is equal to 178. So that's the measure of the last angle. Okay. Next problem, number 36. A standard yield sign is 20 inches on each side. What is the sign's approximate area if it's an equilateral triangle? Okay, so this is an equilateral triangle. Every side is the same length. If this side is 20, so is this side and this side. Area of a triangle, the formula is 1/2 VH, okay? If we're trying to get the height of this triangle, which we'll need in order to get the area, we'll start by splitting this in half. So this side would be 10, okay, 20 divided by 2. We need to use Pythagorean theorem to get the height, so 20 squared minus 10 squared gives us about 17.3. That's your height. Okay. All right, and then we plug that in. So 1/2 20 times 17.3, 5 times 20 times 17.3 is equal to 173. Make sure when you plug in for B, you use the whole base and not the half. Okay, our video is at 28 minutes. I don't want the file to get too large because I want it to upload easily. So I'm going to stop the video there, and I'll continue the rest of this review in the next video.